Hi everybody, we're going to do solving quadratic equations using square roots. So I suspect that there's not going to be an x term, there's just going to be an x squared term, which means we do the opposite to both sides in reverse order. So let's see if that's the case. I'm pretty sure. Looking forward to these. Okay, so one way to think of this is that we have some value, v, being squared. Well, v stands for value. And it's being squared and it's equal to 49. Now, most people are aware that 7 squared is 49. It just so happens that negative 7 squared is also equal to 49. And the way we do the problem is that we want to do the opposite to both sides. And a good practice to get into is when you're solving this equation, we want to do the opposite of squaring, which is square root. But there's something extra. Because we're solving for an unknown, we don't know whether they want the positive or negative square root, and it could be either one. So this is a really good habit to get into. You take the square root of both sides. The square root of v squared is v, and positive or negative needs to be written in front of this. So we get positive or negative 7. So v could be 7 or negative 7. And there we go. Now, occasionally, we're going to have more things happening. Not in this one. This is just the square root of 81, which is 9 or negative 9. I just took the square root of both sides, and don't forget the plus or minus. And so Q is equal to plus or minus 9. A couple of different ways of writing that. See if we get a little more interesting one. Not really. This is plus or minus 2. This is plus or minus 4. Because 16, the square root of 16 is 4, not 8. Be careful. 4 times 4 is 16. Oh, this is a little more interesting. Okay, so we have to add 121 to both sides. We have to do the opposite to both sides in reverse order. So we get q squared is equal to 121. And when we take the square root, we want to have the positive or the negative 11. I just added 121 to both sides. There you go. So q is 11 or negative 11. Okay, in this one, we're going to subtract 18 from both sides, which is going to give us j squared is equal to 16. I just subtracted 18 from both sides. And then I take the square root, and it's not 8, it's plus or minus 4, isn't it? Okay, plus or minus 11, same question as before, except that they made it even easier. Okay, in this one, we're going to have to add 89 to both sides. So when we add 89, we get u squared is equal to plus 89. We're going to get 40. And we do get two real solutions because the square root of 40 is plus or minus. And the way that you simplify this is you take the 4 times 10, so it's going to be 2 root 10. You generally reduce that. You could say it's approximately equal to, it's between 6 and 7, and it's really close to 6.5. So 6.4 would probably be the closer one. So approximately plus or minus 6.4. Okay, that's it. Two real solutions. Now, one of the things they were probably looking for you to do is to use the thing called the discriminant, which is b squared minus 4 ac, but it really wasn't that important in this particular case. So this is 2 real solutions. This is going to be 1 real solution. What's the only square that can make 0? Well, 0. 0 squared is 0, and there's only one of them. So it's the only case that you'll ever get 1 real solution is when you have something squared equal to 0. No matter what it is, it's going to have 1 real solution. In this one, same deal. You're going to, the 0 doesn't have any effect, and you have p squared equal to 0, so we have 1 real solution, and it's 0. In this case, you're going to have 2 real solutions. It's going to be the square root of 10, which is approximately 3.14. It just so happens, I think it's 3.13, but approximately. It's irrational, but x is equal to plus or minus the square root of 10. We can say it's approximately plus or minus, I believe, 3.13. But remember, that is only an estimate. This is an irrational number, which means it can't be written as a non-repeat. Well, it can't be written as a decimal. Perfectly, you can approximate it as a decimal. But there it is, 2 real solutions. Okay, here we go. Finally, we have a no real solution. And here's the reason. We get y squared. And when we subtract the 6 from both sides, we get a negative 6. Well, there's no way to take a real number and square it and get a negative, because if I take a square root of 6 and I square it, I get positive 6. If I take a negative square root of 6 and square it, I get positive 6. There is no way to get a negative 6 with real numbers. So we say there's no real solution. There are what we call imaginary roots, and that would be with the I value. And the way we do that is we take the square root of both sides. And the square root of negative 6, it's actually plus or minus the square root of negative 6. And what we do is we take out the square root of negative 1 from that. So this is the same thing as plus or minus the square root of 6 times the square root of negative 1. And this is correct. And this has a special value in mathematics. It's called I. And this is plus or minus the square root of 6i. And this is the actual 2 solutions for this, but they're not real. So they're not real numbers. So we say no real solution. I know, more than you wanted. Sorry, guys. We subtract 82 and we get q squared equals 0. And there's 1 real solution. And when you get 1 real solution with quadratics, it's always 0. Or yeah, it's pretty much always 0. This one's going to be plus or minus 5 because p squared is equal to 25. So we take the square root and we're taking the plus or minus. So we have 5 or negative 5. Don't want to spend a long time. We want to do some of the hard ones, right? Oh, this one's much better. Okay, so we're going to add 52 to start with. So we add 52 to both sides. And that does give us 9, doesn't it? So 64 m squared is equal to 9, because negative 43 plus 52 is 9. And we divide by 64. Remember, you could take the square root first, but it's easier to do it this way. And we get m squared is equal to 9 over 64. And then when we take the square root, it's a fraction, isn't it? And it has a plus or minus on it. So this is plus or minus. The square root of 9 is 3, and the square root of 64 is 8. So it's plus or minus 3/8. 3/8 or negative 3/8. Oh, almost missed it. There we go. $10 or negative 10. We want the square root of 100. It's not 50. Remember, square root. And what do we got here? Okay, this time we have to divide by 3 on both sides. And we get s squared equals 4. And hopefully you recognize that that has 2 solutions, 2 and negative 2. Looks good. And we're going to add 36 and then divide by 9. Well, guess what we get? Can you do it in your head? I'll bet you can. Add the 36 to both sides. You get 9d squared equals 36. And then we divide by 9. And we get d squared equals 4. And then we get two solutions, 2 and negative 2, just like last time. And this one, we're going to subtract the 74 from both sides, and we're going to get the 25, aren't we? T squared equals 25. Because we subtracted 74 from both sides. And of course, t is equal to 5 or negative 5. Looks good. Okay, let's see. Well, they gave us an easy one, 4 or negative 4. I think a lot of people just grab that 8. Be careful. 8 times 8 is 64. 4 times 4 is 16. We're looking for the 16 as the perfect square. Okay, so u squared equals 52. And so we get two real solutions. And I want to write them for you. When I take the square root of both sides, one of the things you want to get in the habit of doing is you could estimate this at about 7.2, somewhere around there. I'm just going a little bigger than 49, which would give me 7. Don't forget this plus or minus. The other thing you want to do is you do want to be able to reduce radicals. And to reduce radicals, you just have to look for what's called a perfect square factor. And it just so happens that 13 goes evenly into 52 4 times. And it's the 4 we're more interested in. So this is plus or minus the square root of 4 times the square root of 13. One way to memorize 52 is to remember that it's cards in a deck, and there are 13 cards of each suit, and there's 4 suits. The plus or minus square root of 4 is just 2 square root of 13. This is an exact answer. It's not approximate or kind of or sort of. This is exactly right. But if you estimate it, you have to write approximately, and that's going to be about plus or minus 7.2. 7.2, I think, is closest. So there are clearly two real solutions. I know, more than you wanted. Divide by 5. Can you do it in your head? Divide by the 5 and we get s squared. Sorry, that's supposed to be an s. Equals 9. We divided by 5 on both sides. So s is going to be 3 or negative 3. Oh, not a comma. There we go. Okay, this time we're going to add 73 to both sides. We're going to get m squared is equal to, man, that sure looks like 81, but it's not. It's 91, isn't it? Oh no, it's, God, I can't add today, 87. I'm going to add 73 to both sides. And sure enough, that's 87. That's a prime number, so there's not going to be any reducing. You just have to take the square root. And can you tell approximately what it's going to be? It's going to be plus or minus. And this is the exact answer. But if I want to get an approximation for that, think about how you're going to do it. It's going to be between 81, which we know is 9, and 100. We call this interpolation. We're looking at a value in between here. We're looking at the square root of 87. Well, the way I do it is I say, oh, this is 6, and this is about 20. And 6 over 20 is 3/10. So I'm going to guess about 0.6. Does that make sense? Oh, sorry, this is 5. God, I can't subtract today. This is 5. Sorry, my bad. 5 over 20 is about 0.25. That's better. 5, because this is actually in formal interpolation, this would be 9 and 5 over 19. But this is really close to 9 and 5 over 20. Well, 5 over 20 is 1/4, so this is exactly 9.25, and this is approximately the same thing. So 9.25 would be my answer, approximately, plus or minus 9.25. Sorry, I can't subtract today. Anyway, there it is. 2 real solutions, way more than you wanted. We're going to add the 28 and divide by the 7, and then we're going to take the square root, aren't we? Because we always go in reverse order. You do the opposite in reverse to both sides. The last thing we did was subtract the 28. We have to add 28. So we get 7v squared equals 28. Then we're going to divide by 7 on both sides, and we get v squared equals 4. And you hopefully know that that's going to be 2 and negative 2. And for most people, they could do that in their head, okay. This one's a little more interesting. Let's subtract the 77 minus 77, which is 4, isn't it? So we get 36h squared equals 4. And if you're not careful, you might think that this is 9. It's not 9. When we divide by 36, this says h squared equals 1 over 9, doesn't it? Yes, you could have left the 4 over the 36, but it's better to have the 1 over 9, because then when you take the square root, you just get plus or minus 1/3. And there you go. Okay, divide by 9 on both sides. And yes, you can divide 0 by 9. You can't divide 9 by 0, but you can divide by 9 on both sides, and you get w squared equals 0, which has one real solution, and it is 0, because 0 squared is 0. There's only one of them. In this one, we're going to subtract the 64, then we're going to divide by 4. Now, be very careful. 64 divided by 4 is 16. It's a little harder to see than most people think. But the problem is that we have a negative, don't we? It's negative 64. And we have 4k squared is equal to negative 64. We're going to divide by 4, and we get k squared equals negative 16. When we take the square root, you can take the square root of negative 16, but you get a what we call a complex or imaginary number. And the way we reduce this is that we take out the negative 1. So we say that's the same as square root of 16 times the square root of negative 1. This is the imaginary part, or the I part. And plus or minus 16 is 4. So there's our solutions. They do have solutions, but no real solutions. And we have one last one. We're going to add the 12 to both sides. Can you do it in your head? I'll bet you can. Add the 12 to both sides. So you get the 32. Divide by 8. Yep, you get 4. And then you take the square root and you get plus or minus 2. So there it is. And that was it. Easy stuff. I'll see you back again. I hope you enjoy it. Bye-bye.